All right, so this is our kind of last sort of quote unquote instructional video here. On both of these. Now, and the other pair, we always had something with sine and cosine on one side, and then the others were kind of vastly different, right? Now, on these, it's a little more nebulous. It's not quite as obvious because we've got cosecant and secant over here, and then we got cotangent over here, and it's kind of like, well, which one do we mess with? Well, think about it. Even if we write cotangent a certain way, if we write it as cosine over sine, it's not going to really give us anything to do with it. And it's the same thing with over here. We have cosecant squared. If I write this out a certain way, it's just going to be 1 over sine squared theta. And that's great that we understand what it means, but it doesn't give us anything to do with it, if that makes sense. So what we'll do then is we'll focus on the other sides, and don't for a minute think that, oh, the right side is always the side that that you leave alone, because that's not how this works, right? It's just happens to be merely a coincidence. So just keep that in mind. So what I'm going to do is I'm going to write this out a couple times just to prove a point that we're just leaving this how it is. All right. And now I'm going to start messing around with this. So what I know I got to do for this, I know that these are both fractional identities. So I know cosecant is 1 over sine, right? And so I put the big fraction bar there, and I'm going to have a complex fraction here. So don't freak out. Not too big of a deal. All right. Now, remember, when we have a complex fraction, it is still just a division sign. It's always just this side, right? So it's this, right, divided by this, right? That's all it is. And so what we're going to do is we're going to rewrite it as a division problem. We're going to break apart the big fraction and turn it into just a straight up division problem. So what you always do, if you remember that, is you have your keep change flipped. So you keep the first term the way it is. So we're going to go 1 over, and I'm going to go back to my black here. Go 1 over the sine of theta, and then we're dividing, right? And we won't do keep change flip yet because I just want to show you this 1 over cosine theta. So that's what this means. Now we'll do our keep change flip. So you keep the first term, and then we change this into a multiplication, right? And if you're ever like, well, it's they're inverses of each other, so it kind of makes sense. Then you have cosine theta over 1. All right, and so now that we have this, we can multiply these, right? And I'm going to do this like Captain Obvious style here just to make sure we're good. So 1 times cosine theta over sine of theta times 1, right? And those are classic examples of, of the identity theorem, which is anything times 1 is just that thing. So you have cosine theta over sine of theta equals cotangent theta. Well, by definition, cosine theta over sine theta is cotangent theta. And so now we have gotten to our identity step where we proved it, and we're good to go. All right. So let's do this next one, and we kind of already determined that we're going to leave the cosecant squared side alone, and it's going to probably be a bit like this one, right? Maybe not involving keep change flip, division of fractions, but we'll have some things going on. So 1 plus cosecant squared is not necessarily one of our identities, right? But think about this: I just made a common error. All right. And my common error I made is I said, oh, I was thinking of this as one thing, but I can't pull this one thing out because the order of operations dictates that I have to deal with this as a unit, not this, right? That's not good. That's not what we're doing. We have to deal with this as a unit. So that's what I'm going to do. So I'm going to leave this as 1, and then this becomes 1 over sine squared. All right, because that's what cosecant is. Well, cosecant's 1 over sine, so cosecant squared would be 1 over sine squared. And then times cosine squared theta over 1. And I'm just putting it over 1 to kind of show that, we're going to have a little multiplying fractions going on here. And so if I simplify that, we have 1 over cosine squared theta over sine squared theta. We're just going to copy the other side down. We're not even really thinking about cosecant squared right now. Now, cosine squared over sine squared theta, guys, is cotangent, right? Or cosine over sine is cotangent. So cosine squared theta over sine squared theta is cotangent squared theta equals cosecant squared theta. And you actually have just written down one of your theorems, but just to show that we want one side equal to the other side, we will use that theorem to show that this is equal to cosecant squared. And then you get cosecant squared theta is equal to cosecant squared theta. And you have your official identity, and there you go. So a lot of writing with these, but you know, it's not, you're not doing really any hard math. It's just mostly remembering some fraction operations, and also like it is just, you know, kind of like problem solving common sense, you know, 101, and just it's a good refresher and a good reminder of how we do things. Alrighty, so thanks for watching these. The next video, so the fourth and final video in the series, is going to be just going through setting up a couple of the homework problems for you. All right, have fun.